cap sealing success. This is Mark Plantier of Enercon Industries, and we'd like to thank you for your interest in today's topic. Before I introduce our expert panel, I'd like to cover a few items. Today's webinar is being recorded, and all attendees will receive an email enabling you to access the webinar and presentation slides when they are available online. That email will also include links to these valuable resources provided by Enercon and Selig Group. It includes the new induction sealing ebook, Getting Started with Induction Cap Sealing, Pressure, Heat, and Time, Selig's Technical Guide to Successful Sealing, and a setup log and checklist that you can use in your own operation provided by Enercon. If you have any questions during the presentation, please use the GoToWebinar question tool to type in your questions at any time during the webinar. At the end of the webinar, our panelists will answer as many questions as possible. If we do not get to your question, we will have one of our panelists follow up with you. Today we're fortunate to have three veterans of the packaging industry and induction sealing. B.J. Raddick of Selig Group has been with the company for over 24 years and is their regional sales manager. B.J. is an active member of the IOPP organization. Jeff LaGrange has been with Enercon for over 20 years and is the company's cap seal product manager. Jeff is intimately involved in the design and development of Enercon cap sealers and is in communication with packaging professionals such as yourselves regarding their induction sealing challenges. Ryan Schilke is Enercon's Vice President of Sales. He has over 18 years experience in the packaging industry. He is a member of the Board of Directors of the Association of Sauces and Dressings and is also a member of the PMMI Global Marketing Committee. A preview of what you'll learn today, the 5 secrets to achieving a perfect seal. First, the importance of optimizing your materials and your equipment for your application. Second, understanding the principles of the induction sealing process, the variables being heat, pressure, and time. The importance of setting up an operating window, the importance of documenting your results, and the #1 cause of induction seal failure, lack of torque. With that, I'd like to turn it over to B.J. Raddick from Selig Group.
Thanks, Mark. I'd like to thank Ryan and the Enercon team for inviting us to participate in today's webinar. We're going to talk about some of the key benefits of induction seals and also review how to choose the best inner seal for a specific application. #1 benefit is leak prevention. In 1960, a gentleman by the name of Jack Palmer invented the first induction inner seal. Mr. Palmer worked for the FR Corporation, who manufactured a line of photochemicals. The FR Corporation had been experiencing a tremendous amount of leakers and recognized the need to improve their package to address the high leaker rate. Thus, induction sealing was actually born. Then in the early 1970s, Union Carbide joined in. Union Carbide had been dealing with an increasing number of leakers of their own, and including fines from the Department of Transportation for leaking Prestone antifreeze. After the Prestone brand converted to induction sealing, the entire industry quickly followed suit. Today we see induction sealing across many industries to address issues with leakers, which includes a very high level of activity in the beverage and dairy segments today. Tamper evidence. I'm sure you'll all remember the Tylenol tampering cases in 1982. 7 people died in the Chicagoland area after ingesting Tylenol that had been tampered with and laced with cyanide. The Food and Drug Administration sprang into action to establish guidelines for tamper-resistant or tamper-evident packaging, and again, the induction seal was chosen as a primary technology to address those issues. Now, induction sealing is used by the pharmaceutical industry around the globe to provide tamper evidence. In addition to leak prevention and tamper evidence, induction inner seals preserve freshness. The induction inner seals help extend the shelf life of products and also preserve freshness. Product freshness is an important concern across most segments, but especially critical in the food and beverage industry. Now, many of the products that you purchase in the grocery store use induction inner seals. Peanut butter market is a good example, and whether you buy Jif or Skippy or Peter Pan or a regional brand, they all use induction inner seals. What's interesting to note, one of the main reasons the peanut butter industry converted to induction seals was actually to address a non-malicious form of tampering that was caught by video surveillance at supermarkets. Shoppers were actually caught conducting their own taste tests in the store aisles. They would choose the brands they wanted to compare and take the caps off, stick their fingers in the peanut butter to get a little taste, then recap the jars and return those packages to the store shelf. And if that sounds gross to you, that's because it is. So those are some of the benefits that induction inner seals provide. We'll talk about choosing the best inner seal for a specific application. Now, when choosing a specific material, one of the questions you want to answer is whether you want a clean peel material or tamper evident. The definition of a clean peel would be a structure where the entire seal can be removed from the lip of the container with no residue. The opposite would be a tamper evident seal that leaves a physical residue on the lip of the container, and that residue is the tamper indicating feature. Now, ease of access or puncture resistant may also be a functional requirement. You know, do you want to be able to puncture the membrane with your finger, or would you prefer to use a knife or a screwdriver to gain access to the product? So once we define what kind of removal characteristics you're looking for an application, the next question would be the container resin. What's the resin used to make the container that we're sealing to? Whether it's polyethylene, polypropylene, PET, etc., that will help us match up the specific heat seal film necessary to seal to the container. Once we have that clearly defined, the fill method or processing conditions are important, whether it be a cold fill, hot fill, flood or retort, or other process. That information is critical to recommend the best material for a specific application. In addition, we need to know what the product is that you're packaging. Some products that are aggressive or volatile, have high acids, may require a barrier layer between the heat seal film and the aluminum foil to protect that foil from corrosion or perhaps delamination. Talk about some of the types of induction seals. The first type is a one-piece or single element structure. They're typically used in the food and beverage industry, including dispensing caps for condiments. Here we have the entire structure that will seal to the container, and nothing is left in the closure for resealability. The one-piece induction seals construction is of a backing. The backing layer is typically a chipboard, paper, or foam structure available in different thicknesses that's permanently bonded with a glue or adhesive to the aluminum foil. That backing is there to provide rigidity for processing and to help keep the foil in the closure. Another type would be the two-piece or separating induction seal. The backing is bonded to the foil with a temporary adhesive designed to allow for separation during the induction sealing process. This will leave a backing in the closure for resealability. The temporary bond is typically a wax or polymer bond. This shows the backings of the two structures here. We have a backing, again, that's typically pulp or foam, available in different thicknesses. And it's there to provide resealability. This is a tab version. There are many consumer convenient tab products that have the half-moon shaped tabs, such as the lift and peel or top tab. Simply put, the lift and peel is a one-piece option, and the top tab is a two-piece option that leaves pulp in the closure for resealability, and they're both designed to be easy to remove for the consumer. So that covers the main aspects of the induction inner seal, and I'll pass the floor back to Ryan to discuss matching the induction sealer to the application.
Thank you, BJ. There are a number of variables that we need to consider in addition to the points that BJ has talked about when we look to match an induction sealing machine to your application. One of the first things that we look at is what's the style of the closure that you're using. Are you using a relatively simple, flat, continuous thread closure? Get a little more complicated maybe with the child resistant, or even more unique as in various dispensing closures. The reason why we look at these components of the closure is because where it puts the foil in relation to the bottom of the sealing head, or what we like to term the sweet spot of the induction sealing process. Number of variables that you see here is oftentimes you'll have a closure, say a 38 millimeter closure with a relatively similar size foil. That's very straightforward. But then you get into applications like you see on the left with a coffee container, where the closure itself is significantly bigger than the foil in hand. You'll see that many times on coffee packages or on condiment packages such as ketchup, where you have the upside down bottle which provides the convenience to the consumer. Many times there the foil is significantly smaller in diameter than the closure. We also need to consider where the foil sits within the closure. You see on the mustard bottle here, there's an arrow pointing to the top of the closure itself, and the bottom arrow points to where the foil actually sits. This is important to note because as you get further away from that sweet spot of the induction sealing process, that field dissipates, and we need to make sure we accommodate for that. The other component that we always look at with closure design is what sort of torque, what sort of application torque can be provided, and we'll talk more about that here in just a couple of minutes. So we have a range of options that we're able to provide. Pictured here is everything from our Super Seal Max induction sealing machine, which is used in high-speed applications, all the way down on our lower right-hand side, the Super Seal Junior, which is used in small-scale production, maybe people just getting going in the induction sealing process, to lab environments. What's important to take away from this slide is to think about the fact that we have two components to every induction sealer. You see the top part, the stainless steel part of these systems, is what we term the power supply. That is one of the pieces that we need to choose when we're looking at an application. The bottom part of the black part that you see there on each of the systems is what's known as the sealing head. And we will look at each of those and look at what options are correct for your application. As we talk about sealing heads, this is a great illustration to kind of understand how a sealing head functions. You'll see in each of these images we have white arcs or white lines typically emanating from the center of the sealing head off to the sides, as you see in the two pictures on the right. That is an illustration of what the induction field, the electromagnetic field that we're generating, looks like, even though it is invisible. On the right, we have one which actually just emanates from the side, and that's going to be for specialty closures, maybe very small closures. So we referred to it earlier on that there are three components to any sealing process: pressure, heat, and time. That's going to apply whether it's induction sealing, maybe a conduction sealing process, or something as a bag sealing process, something you may have in various aspects of your packaging line. The first component is pressure, and the pressure in induction sealing comes from applied cap application torque. So this is going to be the process after filling your package. You cap, and the process of applying application torque ensures that the heat induction seal is in intimate contact with the land area of the container. Now that we have contact between the liner itself and the land of the container, we have to apply a source of heat. In this case, it's the electromagnetic field that the induction sealer generates. What's happening here, this electromagnetic field couples in with the aluminum foil and generates heat, which causes the heat seal layer on the bottom of the foil to begin to flow and ultimately adhere to the container. This pressure and heat has to be applied for a given amount of time. With induction sealing, the time is typically dictated by your conveyor speed. This is a piece that many packagers measure in bottles per minute, and what we ultimately need to get to is how fast is the bottle traveling in either feet per minute or meters per minute. One important note to always remember is that the relationship between the power output of the machine and the line speed is not linear. This is a good example of this would be maybe you decide you want to run your line speed 10% faster. That does not necessarily mean that increasing the power level on the sealer by 10% will seal that. It, of course, is the case that it may coincidentally work that way, but in general, that relationship is not linear. Now I'd like to hand the mic over to Jeff LaGrange to talk about establishing your cap seal operating window.
Thank you, Ryan. I'm talking about your operating window. We've got a graphic here that kind of shows the different stages that you can find yourself in when talking about an induction seal. Of course, we all want to be in the good seal area. What we're going to talk about for this is establishing your sealing window and finding the output that assures you'll stay in the good seal range, even if you've got slight variances in your torque or your bottle height or your line speed, for example. But before we get into that, let's briefly discuss the different seal stages represented in this graphic. Some are very obvious, like the no seal. The liner simply does not stick to the bottle. Now, a partial seal can also be obvious, like in this picture, where half of the liner is not stuck to the bottle. But it can also be a little bit more subtle, where the liner can appear to be sealed, but there's a small leak in one area, or it's just not strong enough to pass your seal test that you've established. Now, a good seal, of course, means that it's sealed all the way around with no leaks and no signs of overheating. This is where we all want to be. This is the goal. Now, lastly, an overheated seal can be sealed just fine, but you'll see excessive wrinkling in the foil, perhaps, or if it's a two-piece liner, you can have burning on the backing material like we've shown in this picture. Or if there's a foam backing, you can the foam will show signs of melting away, and you don't want to be in this situation. Now, to set up your operating window, there's 4 basic steps. First, you have to make sure your system is set up properly. If you want to get a good, consistent seal, you need to have proper setup. Next, we'll talk about finding your low end of your sealing window, followed by finding the high end. This is what we mean by the sealing window. There will be a range of outputs in which you're able to get a good seal, so we need to define that range. Lastly, once you've defined your sealing window, you need to choose and record your preferred set point. Some people may want to go smack dab in the middle of the green section, giving the maximum room for bottle and torque tolerances, for example. Others may prefer to be somewhat on the high side of the green area because they'd rather be a little overheated than not seal. This will be up to you and the policies of your company. But basically, as long as you find yourself within the green area, you'll have a bit of a cushion to take up any of those tolerances discussed earlier. So the first step is finding your sealing window is making sure you have a proper setup. To run these tests, you'll need to make sure you're getting the consistent torque out of your capper, and that's the pressure part of the equation. And you'll need to be running at the production line speed. That's the time part of the equation. The rest of the setup involves the heat portion of the equation. To get good seals, you need to make sure the bottles are traveling straight under the center line of the coil. Make sure that the coil is parallel to the conveyor. Now, it's important, this is parallel to the conveyor, not parallel to the floor. Not all conveyors are parallel to the floor. Now, this will ensure a constant air gap as the bottles travel underneath the coil. You need to check that the coil is parallel both side to side and front to back to make sure that everything is even. At Enercon, we recommend an 1/8" gap. It'll give you the most performance and allow for the bottles to safely travel underneath the coil. We provide a gapping tool with every system to aid in this gapping. Once you've got your system set up properly, it's time to start running some tests to determine the sealing window. So first we need to find the low end of the sealing window. This would be the minimum output in which you get a good seal. In this example, we're going to start pretty low at like 40% and the plan is to work our way up to the point where we've determined where the minimum seal point is. So we run at 40%, relatively low, and we find that we get no seal. At this point, we'll want to increase in relatively large increments. We recommend 5% at a time, and run the second test at 45%. 45% test still gets no seal, so we again increase by 5% for the third test. At 50%, we find that we get a partial seal, so we know we're getting close. From here, you should increase the output by 1% until you get an acceptable seal. So we run at 51%. We find that this is still a partial seal. We run a few more tests and we kind of skip them in this graphic. Eventually we find out that at 58% is where we finally get an acceptable seal. This would be the low end of your sealing window. Now we need to find the high end of the sealing window, or the maximum output, where you still get a good seal and see no signs of overheating. Let's start at the minimum point that we just found, say 58%, and we'll turn up the output in increments of 5% again. So we go from 58 up to 63. At 63, we're still getting a good seal with no burning, so we'll increase by 5% again. Now that we're at 68, we see that we've crossed over into the overheating range. So we'll need to back off a little bit at a time. We know we're very close. We're within 5%, so we're close. So we'll decrease by 1% at a time. We'll run at 67%. We're still burning a little bit. Eventually, we find that at 65%, we're getting a good seal and there's no overheating. So this would be the high end of your sealing window. Now we know where our minimum and maximum outputs are. We can make an informed decision on where to set the output of our sealer in production. Many people will put it right in the middle, say 61 or 62%. Others, as mentioned, may want to be closer to 63 or 64. But basically, as long as you put yourself within the green good seal section, you've given yourself a little cushion to take up things like bottle height tolerances, torque tolerances, and things like that. Now let's say you didn't follow this procedure and simply chose, say, 59%. You ran a test. You ran at 59%, you see that it's a good seal, and you decide, well, that's where I should set my sealer for production because I got a good seal. Well, since you didn't find your sealing window, you wouldn't even realize that you're actually right on the edge of losing your seal. And that's not a good place to be. This is why finding your sealing window is so important. Now, all of this only helps out a little bit if you don't record your data for future reference. You know, once you found your sealing window, you know that for this particular product, assuming the setup is proper, you can run at 61% and you'll be in the middle of your sealing window. You should record at a minimum a name for the product, the cap size, the conveyor speed, and the output level. We can provide you with a relatively simple sheet that can act as a bit of a log that you can hang next to your machine for reference. Or if you prefer, we've got a sheet that's a bit more of a setup checklist that has a bit more information on it. This can be used anytime the product changes to make sure the proper steps have been taken to assure a good seal. Those of you that need to validate your line will probably find this type of sheet more useful. Now, chances are you aren't just sealing one package. Not only are the sizes of the packages probably different, but the speed they run at is probably different as well. With our new recipe management application, you can store power settings for a wide array of packages that you seal. Your operators will then be easily be able to pick the recipe, minimizing the changeover time between jobs. So we've talked a lot about the different kinds of seals. Let's talk about how you can determine if your seal really is good. Keep in mind that there are no ASTM guidelines for seal integrity. There are too many applications out there for anyone to generalize them all with a single standard. Most companies will develop their own guidelines based on their particular application. Some simply squeeze the sealed containers and look for leaks. Some will vacuum test the containers. I've even had one tell me that their test was to seal a bottle, cut off the top, invert it, and put iodine on the inside of the liner and leave it overnight to see if it leaks. Your company will have to determine what works best for your product and for your market. But generally, things to look for in a good seal are the same in almost all applications. You'll have good adhesion all the way around the seal. This is a basic requirement. You should see minimal wrinkling in the foil liner, as this indicates too much heat. Lastly, you should see no discoloration in the liner or on the backing material, which would also indicate too much heat. This particular liner has no backing material, so you can see that the wrinkling is minimal. If you're using a foam-backed liner, like the larger picture, you should see no foil. When I say that, I mean with a foam-backed liner, if the liner is overheated, the foam will tend to shrink around the edges, and you'll see the foil underneath it, or melt away at the actual seal area. Here you can see that the foam is intact all the way around. With two-piece liners, you should also look at the pulpboard left in the cap. You should see no indication of overheating, which will mainly show up around the edges. Lastly, you should use your nose. If it's been overheated, you most likely will be able to smell it. There are other ways to evaluate your seal. You can use vacuum chambers to test for leaks. Some companies have actually shipped crates of the product across the country for a bit of a real-world kind of test. There are some vision systems on the market that can assist in determining seal quality. There are some systems that apply pressure to the bottles to check for seal integrity. And lastly, you can shake, squeeze, or like the guy in this picture, stand on your bottles. I'd say this guy's got a pretty good seal. Here at Enercon, we've got a submersible vacuum chamber that allows us to not only see if the container is leaking, but where, which can be very helpful at times. Give us a call if you'd like to get more info on a test chamber like this, and we can point you in the right direction. Now, people have asked, can I test for a seal right after it's been sealed? Well, yes and no. We realize that the best time for you to test is right after it's sealed, but you need to be a little bit careful about that. You don't want to wait, because you don't want to wait for a whole pallet's worth of material to go through to find out that you're overheating the product. However, you really do need to let the liner cool down sufficiently before you test. Usually if you wait about a minute or so, that will give the liner enough time to cool down. Also, keep in mind that with some clean peel liners, they can take up to 24 hours to fully set. So while you know that you've got a good seal, the peel strength may be different in the next day. There are all kinds of things you can run into when inspecting an induction seal. Let's send it back to Ryan for some of our best troubleshooting tips.
Great, thanks, Jeff. Now that we know what good seals look like, the steps going into picking a sealer and choosing a foil seal material, we'll talk about those cases when you do have a problem. We don't like to see problems, but they do crop up from time to time. With any problem that we see in induction sealing, you ultimately see the after effect, the problem, and it really comes down to identifying what is causing the problem. The first question that we always ask is the problem consistent? If it's not, it makes it a bit more difficult. If it is, it helps to start point to what the problem might be. So the types of problems that we're going to review are no seals, partial seals, underheated and overheated seals, as well as inconsistent seals. The number one cause for sealing issues is improper application torque. And typically that is either going to be insufficient application torque or inconsistent application torque. And we see both of them in the field. They're both very common problems that we see in the field. A good rule of thumb to live by is that you want to apply approximately half the diameter of the closure in inch-pounds as you're applying the torque. But what we will always recommend is that you consult with your closure manufacturer as to what the right torque amount should be for your application. So what does your seal tell you? Looking at the seal is often going to give you a good indication of what problem you might be having. So what happens when you're not getting a seal? The the obvious question that we ask is the sealer turned on? Typically the answer to this is yes, but it does happen sometimes where maybe it's not turned on, and we have a couple of solutions for this. You can buy a flashing light, which would indicate it glows green when the machine is running or flashes red when it's not, or if you don't see any light at all, you know that the machine probably is not turned on. You can also integrate the system electronically to your line control that will send a signal and say, yes, we are sealing. Another case for checking a bottle with no seal is there a liner in the cap? This is a case where foil detection either prior to induction sealing or in the capping process is very important. Looking at those two things can take out some areas of gross failures that you may see, and eliminating those helps you get closer to achieving a perfect seal. The other question we will always start with is, does your current setup match the data that you came up with when you documented your operating window? If it does, what's changed? Has your line speed changed? If there's no seal, have you sped up your line and not adjusted the sealing machine? Has your container material changed? This is an important part. If you're going from possibly a polypropylene or polyethylene bottle to PET, there's a good chance that your liner material may need to change as well. In the same vein, you always want to make sure that you know specifically what lining material your cap supplier is providing. If there's a change from one manufacturer to another, that can cause problems with operating windows and sometimes compatibility. Another area to look at when you're not getting a seal is, do you have insufficient application torque? Partial seals occur in a number of cases. Oftentimes they occur when the bottle is not traveling down the center of the sealing head. On all of the sealing heads that we produce, you'll see that there's a little sticker on either end that says center line. We've actually integrated a great feature into our new Super Seal Touch and Super Seal Max systems, which will shine a little red light down onto the center of the conveyor, which will give you an idea, a quick visual to say, is my bottle traveling down the center? If you're not, what will happen is one side of the package will typically get more heat than another, and thus leaving a portion of the package unsealed. It can also occur with low application torque. If you have a cocked cap or a misapplied cap, that a partial seal can also occur. You'll also see this if you don't have proper bottle and cap match. If the cap bottoms out on the bottle somewhere, maybe on the shoulder of the bottle or somewhere else, you may not get sufficient contact all the way around the surface of the land area, thus causing a partial seal. Also very evident if there's a saddle or a depression in the land area, or likewise a ridge, which also often occurs at the parting line of a container. Underheated seals occur typically when your output of the machine is too low or your line speed is too high. And what you're going to see here, this is typically when you're getting a partial seal. The liner material doesn't adhere properly. It probably doesn't have quite the peel that you're looking for or quite the strength. On a two-piece liner, which is what the picture shows here, you kind of see a swirling effect. And what's happening here on a two-piece liner, you're not getting proper wax absorption into the pulpboard secondary liner, and you end up having a little dollop of wax on the center, which when you twist the cap off, you're going to feel it takes a bit more removal torque, and that's actually trying to break that bond, that mechanical bond that's there, and will ultimately swirl the liner. Jeff alluded to overheated seals and what they can look like. Here are a couple of good pictures. The top picture indicates a single piece lining material where the foam backing has actually started to melt away. This is obviously a problem cosmetically, but it's also very important from a product perspective. You're going to do two things. One, you're going to smell a burning sensation, which not only occurs outside the package, but inside the package. And you're also going to damage that heat seal layer that comes in contact with your product, as well as any barrier layer that's put in there as well. Two-piece liner, the picture that you'll see on the bottom is the actual backing layer that's left in the cap. You'll see that it's either discolored, starts to get brown, or even black. This can occur typically, again, you've got the output of the sealer too high, your line speed's a bit too low. Can also occur when you have a cocked cap. Other pieces you want to think about in your sealing process, one of them we've talked a lot about is speed, but more importantly, inconsistent speed. If you've got a conveyor that's maybe a bit jumpy or jerky, that impacts the speed of the bottle traveling down the line, that is a piece that you want to work to rectify. You always want to pay attention to any material changes, whether that's in your container, your closure, or your liner. Make sure you always know what materials you're using and are they indeed compatible. One thing that's sometimes overlooked is how you actually store your closure and liner. It's important to look at the manufacturer specs on how they should be stored. Can cause a problem, especially in two-piece liners. We see it sometimes where they'll be stored improperly. Maybe the wax begins to melt because it's stored in too hot of an environment, and then going through the induction sealing process, we have release issues that occur there. The other piece, and I mentioned it a little bit before when we talked about partial seals, you always want to make sure that you've got a good bottle and cap match. That is oh so important. If the two don't match, oftentimes you're not able to get proper application torque. So let's say you do run into an issue. What's the sort of information that we need to know? We want to know closure information. Who's the supplier? What's the size? What's the style? What sort of information can you get from lot numbers, pallet numbers? If it's a roll of induction seal material that might be used, do you have serial numbers there? Any bit of information you can get us relating to the materials helps us trace the problem. From a machine perspective, we're going to want to know who's the manufacturer and what's the model that we're using, as well as what is the serial number of the system. What type of sealing head is being used? Is it a tunnel style, flat, or one of our universal sealing heads? Also want to know what the settings are. You established your operating window. What are you running at, and what's the line speed as well? Then it really comes down to just asking about the application. Is this a new application, or is it something that you've run for many years? How's the product being filled? Again, this kind of goes back to fill temperature, but also fill, is it a flood fill where the product itself is touching the liner? Want to know about the line speed, as well as are you measuring both the application being applied at the capper and then ultimately the removal torque as well. So we talked today about 5 secrets to achieving a perfect seal. We talked a lot about torque. It is one of the most important pieces. You want to document your results. You need to optimize your materials and your equipment for your application. It's always important to remember the pressure, heat, and time equation, and it's critical to set up and know your operating window for each product that you're sealing. As Mark mentioned earlier, after the webinar, you'll get an email with access to Enercon's new induction sealing ebook, Selig's Pressure, Heat, and Time Technical Guide, and a setup log and checklist that you can use in establishing your operating window. I want to thank B.J. Raddick from Selig for joining us today, Jeff LaGrange, and now we'd like to open the floor to your questions. Please go ahead and submit them. We've been getting some great questions coming through so far. We will answer as many of them as we can in the allotted time. If we don't get to your question, know that one of us will reach out to you and answer any questions that we might have not been able to get to. PJ, here's a question for you. Is there a way to prevent caps from backing off or loosening up due to temperature changes?
Okay. Due to temperature changes, certainly after the induction sealing process for child-resistant closures, retorquers are commonly used to ensure that the closures don't back off or the child-resistant feature is still in effect. As far as temperatures, outside temperatures affecting how a closure might perform, I'm afraid I can't really answer that intelligently, but I'd be happy to take that offline.
Jeff, here's a question for you. When and why should sealing power be lowered from 100%?
Well, we talked a little bit about the sealing window. If you're running at 100%, now let me back up a little bit. This may be with regards to a Super Seal Junior. But let's talk about this in two situations. On a standard sealer like our Super Seal on a conveyor, there are very few applications where you would want to run at 100%, because if you're running at 100% in the middle of your sealing window, you probably don't know where your top end of your sealing window is. So you would typically not want to be running at 100%. The machine can handle it, but it's not the best for your application. Now on a Super Seal Junior, which is a handheld unit, it's a little bit different in that you don't have the conveyor involved to determine your time. You can select the time with the timer on the front of the unit, and in that situation, it's perfectly acceptable to be running at 100%. It will give you your fastest seal times. There are other applications where sometimes you can turn the power down, and you can get a little softer feel from the field, and it will seal a little bit differently. But that's really just from application to application. It's a lot of it is trial and error.
Okay, we've got a question that asks, when would you use a tunnel-style sealing head versus a flat sealing head? This is a great question, and one we probably deal with every day, and that really depends on the closure style and closure diameter that you're using. If you're typically using something below, say, a 53 millimeter enclosure and smaller, and you're mostly running that size closure, we'll typically recommend a tunnel-style sealing head for that, for your application. When you start going 58 or 63 and above, we'll start moving to a flat sealing head in those cases. They just tend to be most efficient in that diameter. Now, we do manufacture what we call our all-in-one sealing head, which allows us to seal everything from a 20 to a 120 millimeter closure, typically going to be a flat cap, a CT in that case, maybe a child resistant. Anytime you get into any sort of dispensing closure, again, those tend to be smaller diameter, we will use a tunnel in those cases. BJ, here's a question for you. Do shrink tunnels affect liner already sealed?
That's a question we've been asked before, and the answer is no, they should not. Using shrink tunnels is common practice, and it doesn't radiate enough heat to get into the actual foil area to heat or soften the heat seal film, so it should not be an issue.
Jeff, I've heard from heat sealing companies that heat sealing will affect the torque of a cap. Is this true?
Yes, it is true, actually. What happens when the bottle goes through a sealer is we are heating up the foil, which heats up the sealant layer on the back side of the foil. What happens then is that goes to a liquid state, and with the torque applied from the cap, it kind of squeezes out and essentially reduces the thickness of your liner material. So you can put the application torque on at a certain level, and when it comes out of the sealer, the removal torque can be less. So it almost definitely does affect your torque.
Thanks, Jeff. We've got another one here for you.
Okay.
How do we verify that the percentage of the induction sealer maintains consistency?
Well, that is a good question. There are a few different ways. Well, number one, our power supplies are designed to regulate the current in in the sealing head. So the circuitry in there is designed to maintain that output level. One way to verify that is using a stack light, which can be set to alarm you if the power supply drops below a certain level or outside of an acceptable range for your application. We also can monitor a contact that will do the same thing as the stack light and let you know if it drops.
BJ, here's a good question for you. Has induction seal been used in the beer industry?
That is a good question. There have been applications to test products that have a small amount of carbonation. I don't think that there has been extensive testing with products that have as much carbonation as traditional beer products, but it's something that we'd be certainly happy to help support a project and help conduct any testing that might be required.
Jeff, here's a question for you. Is it necessary to use a UPS system or electrical regulators to protect super seal machines?
Generally, no. Our super seals are very durable. They have a very durable front end system on the power system. Also, our super seal touch is designed to accept a variable amount of input power. Now, the super seal touch can run from roughly 190 volts up to 240 volts. Now, that's not to say that a lightning strike in your area that gets in your line isn't going to hurt anything, but it generally is not necessary to use any of these kinds of equipment.
Jeff, to expand on that, are there any sort of instruments that are available on the market for checking or ensuring that the machine is consistent?
The best way is really to check your seals. There was a product that had been floating around, the line patrolman or something like that people had used, and we ran a lot of tests on it, and we found that a lot of times it just injected a little bit more confusion than it did solving problems. And so we don't really recommend anything like that because there are so many variables in checking the strength of your magnetic field that it can't really be covered by just one piece of equipment.
Thanks, Jeff. BJ, do I need a different kind of liner to use when I flood fill a product?
That's a good question, and the answer is yes. For a flood fill environment, number one, we would certainly suggest an all-synthetic material, which would rule out paper or chipboard as a backing. And number two, we would most likely recommend a 1 mil foil rather than a 1/2 mil foil to help provide a wider processing window. And we would probably suggest a thicker foam backing to help compensate for the issues created by the flood fill environment. Good question.
Jeff, when setting up the sealing window, does it matter how many containers are being passed through the sealing head at any one time?
That's a very good question. I see another version of that has come up on our screen here too. The answer is no, it does not matter how many bottles are underneath the sealer. Our power supplies are designed to react to different loads. So as you put more bottles underneath the sealer, they will increase the output as necessary. Now, that's not to say that they're going to turn themselves up. They regulate the current in the coil to keep the magnetic field strength even, no matter how many bottles are underneath the coil. Now, the specific question you asked was when setting up the sealing window. If you would like to run 2 to 3 bottles while setting up your machine, you can, but it's almost like you're throwing bottles away because a lot of these are going to be thrown away at the end of the day.
BJ, can a glass bottle be induction sealed?
That's a question that we are probably asked on a weekly basis. It is possible to induction seal glass containers. It has been successfully done in the marketplace for many years. However, number one, the glass must be treated with a product called AP5 or an equivalent type of treatment like polyethylene or oleic acid. Sealing to glass is certainly a challenge, but it can be done if the appropriate glass treatments are applied.
Okay, we've got a question. Should there be a consistent space between bottles under the sealing head? This is one that we get quite often, and no, the way Enercon has designed our equipment, it really doesn't matter if the bottles are virtually touching or 1 foot, 2 feet, 3 feet apart. The machine will compensate for any sort of differences with 1 bottle in, 2 bottles in, 3 bottles in. The only place where it does play a role is with cap inspection. If you do use cap inspection systems, there does need to be a small distance between each of the bottles. BJ, what would be the problem when the backing is stuck to the foil and stuck to the cap?
Well, it depends on whether it's a 2-piece wax bonded induction seal or a 1-piece single element structure. In the case of a 1-piece structure and the backing is adhering to the cap, that's called back bonding, typically a result of too much heat being applied, melting the polyester film on the backing and sticking to the inside of the cap. In the case of a 2-piece wax bonded structure, that would be an indication of not enough heat or power being radiated in towards the center of the foil disc to completely melt the wax to allow for separation to occur.
Jeff, can I induction seal my products with metal closures?
Well, that's a tricky question. Sometimes yes, sometimes no. Here's what happens when you run a metal closure underneath the sealer. What happens is you're heating up the metal closure instead of directly heating up the foil. So what you're going to end up doing is, I like to refer to it as inductively conduction sealing. So you're going to need to heat up the cap, which will then heat up the foil. It's not the best way to seal that kind of a product, but it has been done, and we would definitely entertain the challenge.
Okay, we've got a question about tabs. Do side tabs or tri-tabs affect the sealing field?
I would say that they don't affect the field, but they can affect how the seal, how the liner sticks to the bottle. Any sort of a tab on the liner is going to do 2 things. It's going to give a spot where the current that we're inducing in the foil can flow away from where you really want it to be flowing. So the heat is not directed right on the land area. It's going to flow out onto the tab. It also has a little bit more mass on there, so that's going to act as a bit of a heat sink in that area that isn't present in the rest of the area. So sometimes when there's a tab, you will see that the seal is a little bit weaker there at the tab than it is for the rest of the bottle. That's just kind of a law of physics at that point.
Okay, we've got a good question that just came in. If bottles get stuck under the head of the sealer, what kind of damage will that cause to the sealer itself? This is a great question, and one which you need to pay attention to. And typically, you can almost eliminate bottles getting stuck under the sealing head by monitoring proper cap application. That being said, there are always cases where they can get stuck. And what will happen if you don't use cap inspection to shut off the machine if it detects a bottle stuck underneath is the sealer itself is really just sitting there and heating the foil and will continue to heat and heat and heat. So you'll obviously do damage to the product itself, but if it sits there too long and continues to heat, and if by some chance it could cause a fire and melt the sealing head, you could have problems with the sealer itself. So that is a reason that we highly recommend at least a motion detection package to shut down the sealer in case anything gets stuck underneath. BJ, we're trying to use the Easy Peel. What does it mean if the easy peel part you pull is stuck to the liner?
If by the easy peel part you're referring to the half moon tab in lift and peel, and it's sticking to a retain liner, that could be an indication of either too much heat's being generated, or perhaps the wrong retain liner is being used in conjunction with lift and peel. We would traditionally recommend a polypropylene-based foam be used as the retain liner with lift and peel. The polypropylene foam is more heat stable as compared to a polyethylene foam, which is also used out there. The polyethylene has a lower melt point and a higher likelihood of sticking to the tab portion of the lift and peel structure.
Jeff, is there a type of conveyor system that works well with your induction system?
Well, really, the only conveyor system we need is one that's going to stay at a constant speed. We've been dealing with a customer just recently that has a conveyor that's kind of jerking around, and I don't mean that in a funny way, but it's not a consistent speed, and they're having a lot of sealing issues. What we ask is a speed that's a conveyor that's going a consistent speed, excuse me, that will give you your best seal performance.
The other piece you want to pay attention to with a conveyor is you want to make sure that your guide rails under the sealer itself are going to be made of plastic and not of metal. It's an important piece to play. You typically need, if you've got 2 to 3 inches clearance between the bottom of the sealing head and any metal, that is usually a recommendation that we make. BJ, will caps seal through water or moisture contamination on the land area? How much is allowed?
Typically, the answer would be yes. Through proper application torque, you're typically able to disperse the liquid from the surface of the lip, and you're able to achieve basically plastic on plastic contact. So application torque is critical. You should be able to seal through the liquid, and of course the heat that's generated would be able to kind of dissipate or make the liquid evaporate. So yes, you should be able to seal through that without issue.
Jeff, I've got another question for you. How do you deal with line speed that is not constant? Line speed might change throughout the run.
Well, that is definitely a challenge. We have addressed that from time to time. We have a product that will monitor the line speed and adjust the output of the sealer accordingly. Now, it requires a little bit of input by the user on the front end to kind of program it, because, like we said, like Ryan said, the output of the sealer is not a linear relationship with the line speed. So there's a bit of a curve that needs to be plotted there. Now, if you think about it, if you're quickly changing line speed, the bottle enters the sealer at 50 feet a minute and exits the sealer at 100 feet a minute, it's going to be pretty tough to get a good seal on that container and really know how high you have to run. But if it's a gradual ramp up, change in the line speed, we should be able to overcome that.
So BJ, we just talked about liquid on the land area of a container. What about dust or more solid particles? How does that impact the sealing process?
Well, obviously in a perfect world you have a completely clean finish to seal to. In many nutraceutical products, powdered products, like weight gainers and whey products do create a lot of dust. There are methods for trying to minimize the amount of dust that accumulates on the lip of the container. Typically a brushing system, or sometimes a slight amount of air is sprayed over that lip of the container after filling to minimize the amount of dust. So it is possible to seal to a contaminated surface, but there is such a thing as too much. I'd be happy to talk to you offline about your specific problem, but it is certainly possible to seal through some level of contamination.
All right, looks like we got time for about 2 more questions. BJ, here's another one for you. Can you over-torque a cap?
Well, you certainly can. One of the Band-Aid approaches to addressing problems with a an induction seal is to increase the application torque. You can certainly get to a point where you're stripping the closure and completely, so that you have no thread engagement at all. So more torque is typically good, but there's definitely a situation where too much torque is not going to help you get a good seal.
Jeff, does a metallic product like iron oxide powder affect the units?
Well, that's an interesting question. Generally, no, for a couple of reasons. Number one, one of the things we're doing, we are inducing a current into a conductor. A metallic powder is not going to be able to conduct current very well. Also, it's usually further away from the coil than the foil is. So the foil is going to attract the majority of the energy, and if there's any powder close enough to absorb any energy, it's not going to be able to conduct any current. So it really doesn't affect the seal very much at all.
Great, thanks. We want to thank all of you for joining us today. We've got a lot of questions here that we'll get to one-on-one. Great questions. We appreciate your time. The webinar is being recorded. You'll get an email probably within the next 24 to 48 hours with the recording, as well as a PDF of the presentation and the items, pressure, heat, and time, cap sealing ebook, and the setup guides. Thanks again for attending, and have a great day.